Hello, this short video explains what the restrict keyword does. This keyword only appeared in the language reference manual for Systemverilog from version 2009 onwards. So at the present time the current standard is IEEE 1800 year 2012. An example of showing the restrict keyword is shown here on this property, on this line. So we can say this looks much like any other property we would write, other than this word here, the keyword restrict. And here's something we're more familiar with, an assertion. And what this assertion is doing, because we need to know for an explanation as it goes on, is that a particular signal never has the value 6. And this particular signal exists inside of a design unit to which we bind this, what's called a verification component. So this bind statement here binds to this design, and that is the signal these properties are referring to. And all it is a free running counter, other than there's an enable signal which is an input to the design. That's the assertion. We're checking that this count value never gets to 6, and of course by design it looks like it can easily get to 6. However, this thing prevents it. And how is that, we may ask? Well, the reason is because this acts exactly like an assumption if you're using formal verification. As far as a formal tool is concerned, it's as if I type the word assume in here. Okay, so indeed, if I load that code in, let me just undo what I've just changed, and then ran that in the tool, what I would see would be my property, which by the way passes, and this property here, the one I've just shown, is treated as being an assumption. So what that means, if we were to look at this property again, the definition of the source code, is we're saying if the count value is 5, then the counter is not enabled anymore. So therefore that explains why we can't reach the value 6, and that assertion is shown as passing here. Okay, so that acts exactly like an assumption, and if you're using formal a lot, you'll be familiar with this. Now, if we were to take the same code and load it in a simulator, what will happen is this property gets completely ignored. Okay. This one wouldn't be, of course. This one would still be verified in simulation, but this one will get ignored. So in order to know why, we need to go and look in the Systemverilog language reference manual. So this is the 2012 LRM of IEEE 1800, and what we can see down here is a definition of what restrict does. I've explained what restrict means in formal verification, as it's talking about here. Informal verification goes on to explain what I just have, that restrict is the same as assume. And in simulation, if I were to highlight this line here, it's not verified in simulation. So what that means is then simulators just ignore it. Obviously they need to check the syntax is correct, but they will not actually do anything with it other than ignore it. So this brings on a question. So why is there a difference then? What is the difference between restrict and assume if formal tools are treating restrict as if it was assume, and they seem to be interchangeable? The reason for this is that in formal verification, the reason for assumptions is to state how inputs behave. So restrict takes this further. What restrict does is something called over-constraining. So often these are called cases, or they are by Cadence anyway. So what this means is you're deliberately over-constraining. So you're writing an assumption, not because you're expecting it to always be true. So always meaning in real life or in a simulation. You're stating an assumption just because it's convenient at the current time. So let's say, for example, if we explain it this way, we want to verify some write functionality of this FIFO here. So the FIFO is the design we're trying to verify. And all we're interested in at this precise moment is verifying some write functionality. Maybe it's new RTL. So we're not caring about all the interactions of reads and writes or what the read functionality is doing, because all we're trying to do is prove some write functionality, some aspect of the write functionality. So in order to make this quicker, easier for the tool, and we get results quicker, we can add this over-constraining to say, because I'm verifying write functionality, don't consider reads. So I write an assumption here which holds the read request at 0. Okay, so this is what this assumption does here. So this will improve the runtime for that particular verification task, and the only reason I've done it is because it was convenient to do it, not because I'm never expecting any reads to ever occur. Okay, so the restrict keyword that we saw, if I were to replace this word shown here, assume, with restrict, it will have exactly the same behavior as shown, but the difference is to the readability. Okay, so someone, if they were looking at this and you'd written the keyword assume, they would think that you've written that property because you're always expecting it to be true, whether you're using a formal verification tool, a simulator, or its operation in real life. If you write restrict, then a formal tool will treat this exactly as it would an assume statement, but it's known to the reader of that statement that restrict is a temporary restriction, i.e. an over-constraining just because it was convenient for a particular verification task at that particular time. Now another difference in how restrict is treated is in simulation. So if I'm doing a simulation and I have this property here, for example, assume, what the Cadence simulator will do is automatically turn assumes into asserts in simulation, because in simulation, assume does not mean anything. And this is in fact a very important thing to do in simulation. Why it's important to verify assumptions used in formal in simulation, i.e. have the Cadence tool automatically convert an assumption into a assert, is because if you verify this light blue box that I'm outlining now with my mouse in formal, then you've written assumptions about how these inputs behave. And all your results are dependent upon you getting that right. There's no further check on them. Okay, so the tool, the word assumption means you're telling the tool it can assume they're true. So if they're not true because you've made a mistake, the tool won't know the difference. It's important to say that these assumptions which you've used to say all your results from formal are valid are actually proven in simulation not to fail. Okay, it's not the same as proving they're always true. It's to say you don't have any simulations in which these assumptions fail. Now the key difference then between the restrict keyword and the assume keyword is the simulator will turn assumptions into asserts, but as we've seen when we looked at the Systemverilog language reference manual, restrict gets ignored. So the temporary restrictions, like I showed here, saying read request is always 0, if we'd used the restrict keyword here instead, it would have been clear to anyone reading this, and also the simulator, that that is a temporary restriction. It's not something you're always expecting to be true. For example, you're not expecting it to be true in a simulator, but the formal tool will honor that as an assumption, which is exactly what you want. So to summarize that then, the restrict keyword is functionally identical to assume keyword if you're using formal. If you're using simulation, the restrict keyword gets ignored. Another point worth mentioning for those of you who have used PSL before is that the PSL keyword restrict, and the usage is shown here, does something completely different to what the SVA restrict does. Okay, so I don't think that it's a direct equivalence between what PSL restrict does and SVA restrict. I hope you found this useful, and thanks for taking the time to watch this.